Alright, this section is going to cover measures of central tendency, which is things that you have most likely heard of before. So the first one is the mean, also known as the average, which you should know how to find. It's the sum of all the data points, you add them all together and divide them by how many they are. Alright, we say that the mean is sensitive to outliers, and here's what that means. Let's choose a really small data set. So let's say that I had a data set of 2, 3, 3, 4. So let's say that was my data set. So to find the mean, I would add all of those together. 2 plus 3 is 5, plus 3 is 8, plus 4 is 12. And then I would divide that by 4, so I would have a mean of 3. Okay. Now, if we take mostly that same data set, but let's make the last number something really big that's way, it would be called an outlier. So it's way different than the rest of our data because 2, 3, 3 are pretty close together. And now we add 12 in there. So that would be called an outlier. Let's see what happens to our mean. So I have 2 plus 3, which is 5, plus 3, which is 8, plus 12 is 20 divided by 4. And so now my mean is 5. Okay, so just changing one number changed my mean by a lot. It changed it from 3 to 5. So the mean is what we call sensitive to outliers, meaning if we have a point that's a lot bigger than the rest of the numbers or a lot smaller than the rest of the numbers, the mean will be influenced. It'll change largely based upon that value. The second measure of central tendency is the median, which again, you should know this already. It's the middle number in the data set. So we put them all in order and we find the middle number. If there is an even number of values, so if you have 6 points in your data set, there will be 2 numbers left in the middle. You just find the mean or the average of those 2 middle numbers. Now, the mean we said was sensitive to outliers. The median is what we call resistant to outliers, meaning outliers don't change the mean as much as they change, or don't change the median as much as they change the mean. So let's take those same 2 sets of data. So if I have 2, 3, 3, 4, if I'm going to find the median, all right, it would be the average of 3 and 3, which means my median would be 3, just like the mean in that first set was 3. But now, if we change the last number and make it an outlier, because 12 is way bigger than 4 and the rest of the numbers, now if I find the median, it's still 3. Okay, so the median is resistant to outliers, meaning outliers don't change the median nearly as much as they change the mean. So sometimes it's better to look at the median than it is the mean because of those outliers. Then we have another thing that you should know, which is mode. And mode is just the most frequently repeated number or value in your data set. If there's nothing that's repeated, then we say there's no mode. If you have something that's repeated the same number of times, so if there's 4 7s and 4 12s in your set of data, then you can have 2 modes. 4 and 7 would be your 12 would be your mode. Alright, and the mode, unlike the mean or median, can also be found for qualitative data. So if I ask people their favorite color and 14 people say red and that was the most picked color, then we could say that red is the mode of that data. So the mode, we can also use qualitative data and find that. Okay, so we kind of already talked about this already, outliers, okay? They are far away from the rest of the data. So they're either much larger than the rest of the data or much smaller than the rest of the data. And they can cause what we call gaps in the distribution. So like when we did our goals dot plot, we had a bunch of teams in like the 2, 3, 4, 5 range. There was lots of dots right there. And then we had somebody way over here at 18. So there's a gap there because there weren't teams that scored 6, 7, 8, 9, 10, 11, 12, 13, all the way up to 18. Okay, so 18, this would be considered an outlier because it's much larger than the rest of the data values. we're going to use the IQR method to find outliers. So IQR stands for interquartile range, all right, which is the difference between Q3 and Q1. So remember when we did box and whiskers? All right, and this is the median, this is the minimum value, this is the maximum value. This right here is quartile 1, this is quartile 3. So the difference between these two numbers is what we call the interquartile range, or IQR. All right, and then to figure out whether they're outliers, we're going to use these two formulas. Okay, so let's say that we had an IQR of 14. Okay, we found the range between the two quartiles and it was 14. Then when we look for outliers, we're going to do Q1. So I just made up some numbers here. All right, let's say this was my min, quartile 1, median, quartile 3, and max. So we're going to do quartile 1 minus 1.5 times the IQR. All right, so 7 minus 1.5 times 14. And when I do that, I get negative 14. So that means that to be an outlier, the number has to be less than negative 14. So if my minimum is 2, then I don't have any small outliers. Then we do the same thing for big outliers. We're going to take quartile 3, so 21 plus 1.5 times the IQR. And when I do that, we get 42. So if my max was 43, that max would be an outlier because it is greater than 1.5 times the IQR. All right, so these would be my minimum and my maximum for outliers. Anything less than this is an outlier. Anything more than that is an outlier.